Hello everybody, in 7th hour physics. Sorry I couldn't be here today. Had to go to Knowledge Bowl. So I'm trying something a little bit new. And yeah, so hi, you can see me, you normally can't see me. I'm just doing this in one shot too, no edits, so let's see if we can get through this. Alright, so we're going to review what we went over yesterday, and then we're going to add in some new stuff, and that's that. So here we go. So yesterday we talked about how this is the main equation that we're going to be using. This equation right here is the secondary equation for weight. Both of these equations are in your reference sheet. So I believe that we had already talked about this one. I'm not sure if we got through, I pointed at it, if we got through this one yet. So I'm going to go through the first one a little bit quicker. We're looking for the weight of the baseball. So we're going to use this equation here. Our unknown is the weight, the mass is given, and then the gravity is negative 9.8 meters per second squared. It's always going to be negative 9.8 meters per second squared if we're talking about the acceleration due to gravity. This is a special kind of acceleration. It's not necessarily just gravity in the abstract sense, it is the acceleration due to gravity. So don't confuse this g with the force of gravity. Force of gravity and acceleration of gravity are two different things. We just plug in and solve for this one. Nothing too fancy. And we end up with an answer of negative 4.9 newtons. It's negative because force of gravity is going down, and we know that that is what that should be. And then yesterday, I think I also told you, don't forget that newtons are defined by being kilograms times meters per second squared. So this kilogram times meters per second squared, they don't magically become a newton. It is by definition a newton. Then the second one, net force. So we have this equation here that uses net force. The issue though is that these two, this isn't solved for net force. So if I go on here, sorry it's a little cut off at the bottom. Let's see. If I do this, hey, hopefully you can see that now. If I stop moving my mouse, you can see that with the algebra, we end up rearranging our equation to get F net equals mass times acceleration. Okay? Then we just have to figure out our givens and unknowns. Our given is 0.5 kilograms and 10 meters per second squared. Combine those together, and we get this. 0.5 kilograms times 10 meters per second squared, and we get this answer right here. I wonder if I'm pointing at it. We'll see if I'm pointing at it when this is all done. But our answer is 5 newtons. Now this next one I know that we did not get a chance to go into in depth, or maybe even at all. So here we go. This one is going to be more complex, so I'm going to spend a little bit more time explaining how to do this one than I did for the last two. This is a meets level problem. So hopefully you haven't had a hard time hearing me. I noticed that my microphone is pretty far away from me. So we'll go from there. All right. Marcus is driving, or go ahead and pause this video so that way the students have a chance to copy this down. Once they're done, go ahead and hit play again. Hopefully you have this all written down now. This problem is going to be a little bit more complex. This is an example of a meets level problem. Meets level problems are going to be less obvious as far as how to solve the problem. So you got to take a step back and go step by step by step. We know that we need to find net force, so I have this written on the whiteboard behind me. You should have this written down. Here we go. I'm going to make this bit my screen a little bit bigger now. Hopefully you can see this all right. I'm going to walk this way. Okay, so we need to find net force. The issue is that we do not have mass in the problem, but we do have acceleration. Yay, score. Okay, so since we don't have mass, we have to figure out, well, how can I get that information? So if we look at the problem, it actually does give us the weight. It doesn't tell us directly what the weight is, but I'll explain to you that that big number at the beginning is actually the weight. We know that g is always negative 9.8 meters per second squared. So then we have to use this equation here to find the weight. Use this equation here to find the mass. Plug that in to this equation, and then we can find the net force. Okay? So I wanted to show you this before I went on to the next stuff. So long story short, use this to find the mass. Once we have the mass, we can find the net force. Okay, let's see if I can make this smaller. So hopefully that's working. So what I'm saying by this is, meets level, you need to do 2 steps in order to get your answers. The givens are not going to be as clear and obvious. So here's one thing that I already mentioned. Weight is sometimes given at the beginning of a problem. So this says 1,500 newtons. It does not say, Marcus is driving this car that has a weight of 1,500 newtons. No, instead it just says it like that. That's like me saying, hey, I've got my bowling ball here. I've got my 16-pound bowling ball. We know that I'm really talking about the weight here. It's not normal for me to say, oh, I'm going to go bowling with my bowling ball that has a weight of 16 pounds. No, I would just say I'm going to go bowling with my 16-pound bowling ball. So that's the same thing here. You got to read into this problem a little bit more. So the steps that we're going to do to solve this problem are use the given weight to find the mass. Oops. I'll move away. So this is the weight. We're going to use that to find the mass. Once we have the mass, we'll use that to find the net force at the very end. So here's my work. Everything at the top is still the same as the previous slide. So like I said, we're going to use the weight to find the mass. So here's this equation. We rearrange it to solve for mass. Force of gravity divided by the acceleration due to gravity. And I end up with this when I plug it in. Negative 9.8 meters per second squared. That should be familiar. But make sure that this is also negative because the force of gravity is going down. So then we have to have that be negative as well. This is a good thing because our mass then ends up being 1,530 kilograms, which is positive because the negative cancels out the negative, so you end up with a positive mass here. We'll slow down for a second to make sure you can copy this down. Feel free to pause the video if students need it. And I'm going to go on to the next part. So we've taken care of this first step here, and then the next thing we need to go to this step. So use the calculated mass to find the net force. I'm not going to point down there because then that little bar pops up, but notice what that like vibrant purple color. We rearrange that equation so that way we have net force, which is what we're trying to find, right? Net force is what we're trying to find in the end. And then we just plug it in and solve. I took this 7.5 meters per second squared, plugged that in here for mass, and then I took my 1,530 or 1,530 kilograms, plugged it in for this, and I get my answer here. It's not pretty, right? It's not a nice 1,000 newtons, or sorry, 11,000 newtons, but hey, that happens sometimes. Okay? So in the end, to review of everything with this one, oh, let's make this bigger. Oh, go ahead and finish copying that down. All right. Hi, everybody. So in the end, the meets level problems are never straightforward. Sometimes you have to do it exactly the way I showed you in this example. Other times you have to do extra steps. It's not always the same, and you always have to do extra stuff. So that's all I got.